Let's use a reaction that we're going to learn much more about next semester, but that is also very useful for making polymers. Imagine that we have this type of molecule. First of all, what class of molecule is this? This functional group that you see here, what kind of compound is this? This is a carboxylic acid. Notice it does have an OH group, but it's not an alcohol because the OH group is attached not just to a regular carbon, an sp3 hybridized carbon, say, but to a carbonyl carbon. So this special case of having an OH group attached to a carbonyl group and then an R group on this side, this is called the carboxylic acid. And then let's combine that with this molecule. So this also has an OH group in it. But now you just have an R group attached to the OH. It's not a carbonyl. So what kind of molecule is this? Well, this is an alcohol. So here's a reaction that we'll learn much more about and more detailed information about next semester. But let's see if you can write down the product. So let's say you combine a carboxylic acid with an alcohol. And I've put a little X in this oxygen because this oxygen is part of the product that you're going to write, part of the organic product that you're going to write. So make sure that whatever product you write, the organic product has this oxygen with the little X in it. And the byproduct in this case is a molecule of water. So sometimes this type of reaction where you take two components and you attach them together and you get rid of or extrude a molecule of water, it's often called a condensation reaction. So you can think of this, just really condensation of water as the reaction proceeds. You might condense water on the sides of your flask or something like that, or you might boil it off and condense it in another flask. So this type of process can be referred to as a condensation reaction. So what do you think the product of this would be? You don't have to think about it mechanistically, really, just in terms of what are the pieces, what do you think the product should be? And I'll give you an additional hint, other than it has the oxygen with the little X in it. It's also a class of molecule that you've probably, I'm sure you've seen before. Well, if we're going to keep this oxygen, maybe we have to get rid of this hydrogen. And then where's the rest of water going to come from? It might come from here. All right? So again, this harkens back to the bad old days of organic chemistry, where organic chemistry got its terrible reputation, where people would just have two molecules. You would put a little box around the pieces that were getting lost, and then they would magically just vanish, and the product would appear. And then the student was just supposed to memorize this, and then another reaction like that, and another, and another, and another. And it just became this enormous and tedious memorization game. So we try to organize things more mechanistically, but in terms of just thinking about the product, let's kind of go back to the ancient ways. So if you were to remove the OH and the H, maybe that's another hint. What product would you expect to form? Well, the product would be one like this. So here is the part that came from the carboxylic acid, and then over here is the part that came from the alcohol. And do you know what this type of functional group is called? So you've got a carbonyl with an R group on one side, and on the other side, not an OH like you had in a carboxylic acid, but an O R prime type of group. this product is an ester, okay? It's not an ether. In an ether, you do have R prime OR, but this is not just a normal R group. It's a carbonyl, so that has a special name. This is an ester. So this is an esterification reaction of a carboxylic acid plus an alcohol, removal of water, and formation of an ester. All right? Okay, so why do we need that? Well, let's come over here to this other board. Let's imagine that we had a molecule like this one that has not just one carboxylic acid in it, but two. And let's say we combined that with an alcohol, except let's make the alcohol have not just one OH group, but a second OH group as well. So, you know, I could number this carbon 1 and this carbon 2. What do you think would happen if I took these and I combined them? I removed water. The claim is that I will get a polymer. This type of polymer, because it's formed via a condensation reaction, can be referred to as a condensation polymer. So can you propose a structure for what this polymer would look like? Just using by analogy this esterification reaction. Remember, an alcohol will react with a carboxylic acid under the appropriate conditions to make an ester. So can you draw this condensation polymer and maybe give it a name, a poly something? This dicarboxylic acid could condense with the OH group of the alcohol to make an ester between this oxygen and this carbonyl. And then you would have another OH on this side, which could do the same. And then this dicarboxylic acid has the ability to form an ester on this side and an ester on the other side as well. Okay? So maybe, let's see here, if we start with this. So here would be the oxygen of the alcohol. That oxygen is connected to carbon 1, which is then connected to carbon 2. On carbon 2, there's another O. And then this O would be attached to the carbonyl of another molecule of this originally dicarboxylic acid. And so on. Here's carbon 1, here's carbon 2, there's another O, etc. over there. And then over on this side, the polymer can continue like this. There's two carbons here, carbon 2, carbon 1, O, etc. Okay? So in drawing a polymer, sometimes it helps to abbreviate the drawing by finding the shortest repeating unit and putting brackets around it. Okay? So see if you can do that. See if you can find one subunit of this polymer where if you just repeated that subunit n times, you would generate the complete structure of the polymer. Well, we might be able to start right here, right? So let's start our bracket there. Or maybe, hold on, let's see here. Let's start right there. Since this carbon, right, came from here, but this oxygen came from the alcohol. So here's 1 unit of what was originally from the dicarboxylic acid. And then here's 1 unit there, and there. There's 1 unit of the original diol. And so then I could close the bracket right there. And you see when I repeat the next one, I start with this carbonyl. There it is. So I could just put, I'll put it in a different color here so it doesn't get lost. I could just put a little subscript N to indicate that this polymer is formed by repeating subunits of this type. Notice, what type of functional group is this right here? It's an ester. Here's another ester. Here's another ester. So what would you call this? A poly what? Well, this is an example of a polyester. Okay? This particular polyester is called Dacron. So you might have heard of Dacron as a type of substance that is used to make fibers, and then you can spin those fibers into cloth and so on. So your polyester suit, maybe it's made out of this stuff.